Okay, sorry about that. So I'm going to talk about different architectures that you can build with OpenNebula on top of VMware infrastructures. So OpenNebula originally was only supported open source hypervisors, but at a later point we introduced support for VMware infrastructures interacting through vCenter. So I'm going to talk about how OpenNebula manages vCenter-based infrastructures. What can you do to manage different VMware infrastructures in different data centers? There's two approaches that can be followed with OpenNebula in this regard. And then I'm going to briefly talk about the new features of vCenter. Of OpenNebula over vCenter that are going to come up in the next release in 5.4 Medusa. And then I'm going to talk about vOneCloud, which is an encapsulated version of OpenNebula on an OVA file for easy deployment. Okay, so this is the picture of OpenNebula and the relationship with the different supported hypervisors. So as you can see, for KVM, OpenNebula goes all the way and gives you all the infrastructure management. So OpenNebula will move the images around and will talk directly with the virtualization hosts and do the capacity planning and so on. For vCenter, OpenNebula delegates most of these tasks to vCenter itself. So when you clone a VM in vCenter, the actual heavy lifting of moving the images around is orchestrated by vCenter. OpenNebula just keeps itself at the cloud management layer, so it offers you multi-tenancy, it offers you service elasticity, and so on. And the top layer is the cloud working layer, and that's where you find OpenNebula interacting with the different public cloud providers like Amazon EC2 and Microsoft Azure. So the idea of OpenNebula on top of vCenter infrastructure is the ability to create a provisioning model, usually based on the CloudView portal, which is a simple self-service portal where users can start consuming resources from vCenter, but all through the OpenNebula interface. So this gives you the ability to provision these resources without obviously giving the access to the vCenter portal to your users. So in this way, OpenNebula acts as a kind of a replacement of vCloud Director. It doesn't offer all the functionality of vCloud Director, but it offers the functionality to create this kind of self-service provisioning portal on top of vCenter infrastructures. So what if you have multiple data centers and you want to offer with a single interface these resources to your end users? So how can you achieve that? Well, it's a couple of ways. So the first option is to be able to have only one OpenNebula instance managing these different vCenter in different data centers. What are the requirements for that? Well, obviously to use a supported vCenter version. So in the next release in 5.4, we are going to support 5.5 to 6.5 of the vSphere stack. And obviously you need good connectivity between all the data centers, obviously where the OpenNebula front end is going to live. If you meet these requirements, then you can have an architecture where you have different data centers with potentially different instances of vCenter managing their clusters of ESX hosts. So this example, you can have a data center here in the US and another data center in Europe, and put a single OpenNebula to control all these vCenters. So the representation that OpenNebula does of these vCenter instances is through the host pool of OpenNebula. So each of the OpenNebula hosts are going to represent a cluster inside each of the vCenters. So you can import as many clusters as you have, or you can just decide to have OpenNebula managing a subset of these clusters in vCenter. Okay, and on top of this host representation and the OpenNebula core, you can plug in all the OpenNebula services, like Sandstone, obviously, the web interface, the scheduler that does the planning of the VMs. And you can have a single set of VM templates offered to your end users. Okay, so they won't even know where their VMs are going to spin. So you have a single set of VM templates. A user says, okay, I want this, I don't know, Apache virtual machine, and OpenNebula is going to know, okay, this Apache virtual machine is running in this vCenter, so let's contact that vCenter, create the virtual machine. OpenNebula is going to extract information of IP address or any contextualization that you may want to do into the VM and report back to the user. And in this way, your user will be enjoying the virtual machine, not knowing where it runs. He shouldn't care in the end. Okay, so this way you achieve a single entry point to a federated OpenNebula cloud. This is not having different OpenNebula instances managing these resources and having the OpenNebula federation, but rather having only one OpenNebula instance managing different vCenters. You don't really need, you need good connectivity, but OpenNebula is not really moving VMs around these different vCenters. So you only need enough connectivity for OpenNebula to interact with the SOAP API of vCenter and be able to monitor the VMs. We usually recommend a latency of under 200 milliseconds, but it may be also possible with higher latencies than that. Okay, if you don't really have that good connectivity, then you cannot really use that architecture, okay? You cannot really have one single OpenNebula managing different vCenters in different data centers if the connectivity is not good enough. What can you do in those situations? Well, you can use the OpenNebula federation, okay? So OpenNebula can federate different OpenNebula instances at the authorization level. So these different OpenNebula instances, they will be managing isolated set of resources. So the vCenter, the different vCenters will be managed by different OpenNebula instances. And again, they won't be moving around images or virtual machines between these vCenter instances. But you can build a system, a federation, where your users can jump from one data center to the other, more or less like you do in Amazon with the different regions, okay, in Amazon EC2. For that end, Sandstone allows you to change the active zone, okay? So imagine you have an OpenNebula federation of 3 different zones. So when your end user logs into the system, they will have the ability in Sandstone to select which zone they want to use at that moment, okay? So if they change their active zone, what happens is that Sandstone is going to directly connect to other OpenNebula instances. It's going to offer you a different set of resources, a different set of VM templates, a different set of virtual networks, different set of images. But you only have a single point of access. You have only one Sandstone instance where your users connect. It's just that if they choose a different zone, they will have a different set of templates, a different set of virtual machines. How does that work? Well, we have, say, the same 2 data centers of the last example, providing that you don't have that good connectivity between them, and you decide to put a new, different OpenNebula in each of these data centers. So what OpenNebula does is building this federation, this single point of access to the cloud, but it's using database replication between these OpenNebula instances to federate the authorization table. So OpenNebula uses a user pool, a group pool, an ACL pool, and all of that is federated through MySQL replication. And this is what happens in OpenNebula 5.2, okay? But in the next version, in OpenNebula 5.4, the model is going to change. So we are not going to rely anymore on the MySQL replication for doing federation, nor for doing high availability anymore, but rather, as Ruben introduced before, OpenNebula is going to implement its own consensus algorithm based on Raft. So they will be able to share the state of, in this case, of the authorization table. So if you create a user in one of the zones, then that change is going to be replicated using the OpenNebula native API, in this case XML RPC. So this is not going to rely on the MySQL replication anymore, which we were having lots and lots of trouble with different users. Okay, so that was a bit on the different architectures that you can build if you have different data centers or even different vCenter instances, which may or may not have good connectivity between them. So now I want to move on to the new features of OpenNebula on top of vCenter that will be appearing in Medusa, the new release that will be out in 2 weeks approximately, if we don't find any showstopper, which I hope we don't. Okay, so the two main enhancements that are going to be made to the vCenter driver are based on the storage and the network. Okay, so this is the idea is to offer more of this virtualization. This infrastructure management through vCenter. So remove some of the functionality that were delegated to vCenter and incorporate that into the OpenNebula drivers. Okay, so this means, for instance, that OpenNebula is going to have a transfer manager for vCenter. So you can choose whether OpenNebula is going to clone the images for you, or you can also keep the old behavior of having vCenter automatically cloning these images. What are the advantages of this new model? Well, you'll be able to have OpenNebula fully aware of the storage of the virtual machines. Okay, so in 5.2, in OpenNebula 5.2, whenever you import a VM template with disks attached, as it should have a VM template, should have disks for the VMs. So OpenNebula is currently not aware of these disks, so you cannot really enforce meaningful quotas on storage for your users, and that's going to change in 5.4. So whenever you import a VM template, OpenNebula is also going to import the disks to their OpenNebula data store. So you have the image representation of the disks associated to a template. This will also allow OpenNebula to offer storage scheduling. So OpenNebula is going to be aware of the space left on the data stores and is going to be able to balance the virtual machine across the data stores. And you can define policies for doing that. So that is going to give a similar functionality as a storage DRS, but obviously without having to acquire the Enterprise Plus license of vSphere. Okay. Also, this will be true not just for VM templates, but also for wild VMs. So a wild VM in OpenNebula, it's a VM that is already running in the hypervisor. That is not being launched by OpenNebula, but you may want to import that into your system and using the permissions mechanism of OpenNebula, assign them to a different user. Okay. So OpenNebula is also going to be aware of the disks of these wild VMs, and it will be counting against the user quotas and so on. Another nice functionality related to storage in vCenter is going to be the ability to resize VM disks. So this is something that's currently possible just in KVM infrastructures, but now you'll be able to having a single VM template and at boot time deciding that you want more disk space. Probably less, but I don't think anyone will want to do that. We also want to offer linked cloud support. Now you can do linked cloud with OpenNebula, but this is going to be a much more integrated functionality in OpenNebula, and we also having the possibility of turning a VM template that doesn't allow for linked clones to one that does directly from the importing mechanism of OpenNebula. So this is going to be a nice way to offer a linked cloud functionality for obviously for the administrators. Also, you have the ability to save your images afterwards. So you can spin up a VM, make some changes on your disk. You can even use volatile disks. So these are disks that OpenNebula create on the fly. So you can add a scratch disk for a VM, and then later on decide, oh, I something really important there, I want to save it. So now you have the ability to save that into the data store and even attach that to new VMs. Okay, probably most important of anything, you'll be able to use non-persistent images. Okay, so these are images that OpenNebula will automatically copy for you. Okay, so you will be able to create virtual machines from scratch. So you don't need to have VM templates in vCenter predefined, but you can have an empty VM template, okay, with just probably just a CPU and the memory. You can import that and then create new VM templates in OpenNebula, referencing this single VM template and attaching new disks, attaching new network interfaces, modifying the CPU. So you can move all this template management from vCenter to OpenNebula. So a similar approach is being followed in network. So currently, what you can do with OpenNebula is basically consume virtual networks that are already defined in vCenter. So you can define a port group, a distributed port group, and import that into vCenter. Into OpenNebula, and then start assigning them to different virtual machines. But in 5.4, you will be able to create these types of port groups and distributed vSwitches directly from OpenNebula. You can create a new virtual network with an associated VLAN, for instance, and when you deploy a VM with a network interface attached to this new network, OpenNebula will go into the different ESX hosts of the cluster of vCenter and create these virtual, these port groups or distributed vSwitches, depending on the technology that you want to use. This will allow to create these isolated networks directly from OpenNebula without the need of any external component, like, for instance, NSX. You're still going to need that if you want to do stuff like VXLAN, but for a high number of use cases, maybe you can just forget about NSX at all if you're using OpenNebula. And you can also create these isolated groups of users or isolated virtual data centers and associate them isolated virtual network with a different VLAN. So before, you need to do it in 5.2, you need to do that at the vCenter level and plan ahead. With 5.4, it will be easier to provision these isolated environments for your users. Still have to do the extra step and be able to automatically provision a virtual data center, including the creation of the virtual network in a single step. So now you need to create this virtual network beforehand and then associate that to a virtual data center. So probably in 5.6, we'll go the extra mile, be able to provision not just virtual data centers, but also new services automatically with a new network attached without having to do that in two separate tasks. Other features that will be present in Medusa is the ability, terrific improvement in performance, especially in the monitoring, which in 5.2, in large infrastructures, it can get really, really painful. And also in the import mechanism. Okay. Also, well, minor enhancements like the ability to define the folder where your VM is going to be residing in vCenter to keep things neat and tidy. The ability to save running VM as a template. So, so talking yesterday with some of you, we also are going to introduce, probably not in 5.4, but in 5.6, the ability to clone a virtual machine. So not clone it to a VM template, but clone it to another VM. That's something that you can do in vCenter. Currently, you cannot do in OpenNebula, but it will be something that OpenNebula can provide and fits into the OpenNebula model nicely. What other things can you do? You can import now white VMs and activate the VNC port automatically. You can use the marketplace, okay? Because we didn't have non-persistent images before. Marketplace, I mean, you could use it, but it didn't make a lot of sense. You can only have one VM on top of the image that you download for the marketplace, and now you'll be able to create multiple VMs from a single image downloaded from the marketplace. Okay, and also, well, some improved metrics. So OpenNebula now is also going to be aware of the disk, write and read operations. Okay, and it's going to present that to the user. Okay, and to finish, I want to talk about vOneCloud. So vOneCloud is really an OpenNebula distribution that it's configured to interact only with vCenter infrastructure. So it doesn't have the ability to control KVM infrastructures or to interact with public cloud providers like OpenNebula does. But if you are an SME and you want to target small to medium infrastructures, then and just with VMware, then vOneCloud might be an option. Also, it's a really easy way to have an OpenNebula installation. So if you are new to OpenNebula or you want to build a sandbox really quickly, then vOneCloud is a good option, because basically it's an OVA file that you download, you plug into your existing vCenter, you spin it up, configure the network. You can start importing resources like VM templates, virtual networks, start creating groups of users and offer that to your end users through the self-service portal. Okay, so it's an easy way to create a proof of concept or to create a sandbox to play around with OpenNebula. It's very easy to install and to maintain, and it's not intrusive. So the way it works is that you can deploy it into your vCenter, play around with it, and then switch it off. This doesn't mean that it doesn't interact with the. Sometimes I get shouts like, it's too intrusive, but I deleted a VM and it got deleted in vCenter. Well, yes, it does something, but you can switch it off at any time and be done with it. Okay, so thanks for listening. If you have any questions about OpenNebula on vCenter or the new functionality, you can ask me now, or we can talk about it later during lunch. Okay? Thank you. So now Ruben is going to talk about OpenNebula and hybrid clouds, right?